Welcome to my third video about dealing with half angle and double angle identities. My goal in this video is to start working on some and showing you some half angle and double angle identities, how they work inside some proofs or verify some identities. We're going to do 4 examples and hopefully get done in this time span of this video. So let's get started. The sine of 2 theta is equal to 2 cotangent of theta over 1 plus the cotangent squared of theta. Okay, well, the sine of 2 theta, we might know, you should know if you have your identities memorized, and if not, start working on it, or at least look at your formula sheet, is 2 sine cosine. So I need to have all this written in terms of sine and cosine and do some algebra, see what happens, and get the two sides to match. Well, what to do? Well, first thing you could do is go BAM! Okay, this is cosine over sine, this is cosine over sine. Find common denominators, do all that good stuff, and it's going to look something like this. 2 cosine theta over sine theta over 1 plus cosine squared theta over sine squared theta. We need a common denominator. So we're going to take 1 and make it sine squared theta over sine squared theta. And that is going to become 2 cosine theta over sine squared theta plus cosine squared theta over sine squared theta. Well, do you know your identities? Sine squared plus cosine squared is equal to 1. And anytime you have 1 fraction over 1 fraction, you can flip that bottom up. So we're going to flip the bottom up and write 2 cosine theta over sine theta times sine squared theta. When we flip the bottom up, and don't forget, sine squared plus cosine squared equals 1. These signs will cancel out. This 1 sign on the bottom will cancel with one of the 2 signs on top. Remember, you can cancel out factors, but not terms. And we get 2 sine theta cosine theta. I'm just turning the multiplication around to perfectly match the identity. And that's okay, because 3 times 5 is 15, and 5 times 3 is 15. And this is the sine of 2 theta. Now, if you're really good at proofs and you just stumbled upon this video, or maybe you're just getting used to them and you're using them to teach yourself how to do these, well, there's a reason why the back of your book says proofs may vary. Because, well, they may vary. That's why I like teaching trig proofs so much, because it's not just, here's 5 steps, and if you follow them in a certain order, you'll get the right answer. You have to think a bit more. Play with the algebra. Do some substitution. See what helps. And for goodness sakes, if you have a Pythagorean identity that's going to help you out right off the bat, maybe you should use it. So I've shown you a proof where I immediately went into terms of sine and cosine, and I did an okay amount of work. And that's fine. I got the right answer. You know what? Full credit. Bam! Well, here's what else. Somebody might be going, why didn't you do it like this? And you're going to go, because I did it my way. 1 plus, yeah, bad singing. Okay, so 1 plus cosine or cotangent squared, well, let's write this. 2 cotangent theta. 1 plus cotangent squared is cosecant squared. Now when I turn everything into terms of sine and cosine, I'm not going to have to find common denominators, and I'll be done much quicker. This is still going to be 2 times cosine over sine, so it's 2 cosine theta over sine theta. And cosecant squared is 1 over the reciprocal identities. That's 1 over sine squared theta. And look, see, I originally had sine squared plus cosine squared there after finding common denominators and after applying that first Pythagorean identity. So I kind of needed to know those Pythagorean identities anyway, regardless of how I did my proof. Anyway, I'm rambling. The bottom's going to get flipped up, become sine squared theta over 1. And once again, the signs will cancel out. And once again, we have the sine of 2 theta. So I did one proof 2 ways. Is that 2 examples or is that 1? I don't know. But when you're verifying identities, you want to, well, always look at the 2 sides and see, like, what's going on, or the angle measures are the same, or the degrees are the same. The only way you can change degrees is through factoring and cancellation. The only way you can change the size of the angle measures is with the substitution of the half angle and double angle identities, or at least how that's all I'm covering. And then see if there's any Pythagorean identities or any of those heavy-duty identities, whether it's sum and difference, whether it's double angle, half angle, power reducing, whatever. That's going to help you right off the bat, and then go to turning everything into sine and cosine, not as a last resort, because it's a really common skill or process, but sometimes you can shorten the proof up by applying some identities early on, if there's any there to help you. Okay, I have a feeling it's going to be a 2-part video for proofs. How about we take a look at the cosine squared of theta over 2, and let's see if we can prove that that equals the secant of theta plus 1 over 2 secant theta. Well, cosine of theta over 2 is square root of 1 plus cosine theta over 2. Not anything to do with secants. So there's no identities going to help me out immediately, like big heavy-duty identities. There's no algebra to do, so we're just going to have to go into sine and cosine and hope that the algebra allows us to get closer, to get the 2 sides closer and make it click until we can see what's going to happen. So secant is 1 over cosine theta. 1, I'm going to go ahead and make common denominators now. 1 is going to be rewritten as the cosine of theta over cosine theta, common denominator, over 2 times 1 over cosine theta, or just 2 over cosine. I'm going to put the top together and get 1 plus cosine theta over cosine theta over 2 over cosine theta. And anytime, again, you have one fraction over one fraction, you want to flip that top or flip that bottom up to the top. Now again, anytime your denominators are an exact perfect match, they're just going to cross out or cancel out. And so we have, wrong color, 1 plus the cosine of theta over 2. Okay. So you could stop there, you can keep manipulating it. If you're not sure how to make this equal that, and you're just totally stuck, then maybe just start playing with the other side. What is the cosine of theta over 2? Well, it is the square root of 1 plus cosine theta over 2, and then there's a power of 2 out here, right? You see it? So that means that it's the square root of 1 plus cosine theta over 2 in a square root system squared. Well, that power of 2 is going to cancel out the radical. And if your teacher wants to only see the work on one side of the proof, then you can sort of manipulate both sides on your scratch work. And then anything on this other side, like the left-hand side, you can kind of just go in reverse on the right-hand side until you get cosine squared theta over 2 here. But as far as I'm concerned, my left and right-hand side match, and I'm done. Bam! Alrighty then, let's do another one. How about one that's pretty straightforward, and then we'll do an easy one, or a hard one. Tangent of x over 2 equals, you might think these are all hard, cosecant of x, and they are when you first start learning them, minus cotangent of x. Okay, if you look at your formula sheet, you'll notice that the tangent of a half angle only has sine and cosine in the 3 versions of that identity. So no cosecants, no cotangents. So we're going to work with the right-hand side. Remember, and also, I haven't said it yet in this video, when you work on proofs, you always want to simplify. Work your way down the tree. Work your way down to the one main trunk. Don't make things more complicated and have 1,000 branches you can go up to. Okay, whatever. So we're going to write this in terms of sine and cosine. Cosecant is 1 over sine x. Cotangent. is cosine x over sine x. Well, shoot, we're done. 1 minus cosine x over sine x is one of the half-angle identities for tangent. Also, don't stop until the two sides are an exact match, please. And do work your proofs straight down, nice clear handwriting, no scribble all over the place. Remember, your teacher, your test papers are giving you the start and the finish of the problem. We have to grade everything in the middle. We have to see every little step, make sure that your algebra is right and your logic is correct. We're not just looking at the answer. We gave you the answer, so make sure your test is gradable, otherwise you might not like what you get back. Okay. At least my kids won't. I'm not going to try and decipher their hieroglyphics. Sine of 3x over sine x minus cosine of 3x over cosine x, and all of this is supposed to equal 2. Hopefully I don't have to erase anything on my board. It's going to be a lot of writing, not a real long proof. Okay, well, I guarantee you some of my students are going to want to say that 3x over x make 2x, or the x's cancel out, or the sines cancel out. This is not the sine times 3 times x. It is not cosine times 3 times x. The cosine and sine, those are math functions. So it is the sine of 3x and the cosine of 3x, and no, nothing is going to cancel. Alright, so get that out of your head. Okay, so we want to make this thing equal to, man, when I look at my formula sheets, I don't have any 3x's. I have half angle and double angles. So this must also include some sum and difference identities. I'm going to rewrite this so that it is the sine of, in here, x plus 2x, that's equal to 3x, minus cosine of x plus 2x, and our denominators of sine and cosine. And I'm not even going to mess with the right-hand side. I think I'm going to need a lot more room, so I'm going to just sort of work down and then possibly need some room over here. I'm going to apply the sum identity for sine. So that's going to be sine of the first, cosine of the second, plus cosine of the first, sine of the second, minus, don't forget the parentheses, because I'm going to write all this, no, actually I'm not going to do it right now. So all of that is over the sine of x, and then minus, apply this one, cosine x, cosine 2x. Don't forget with your cosine functions, your sum and difference identities, to change that middle sign. So it's going to be minus sine of x, sine of 2x over cosine of x. Now I've got two humongous fractions that need to come together, and clearly a lot of stuff is going to cancel because the answer is 2, right? So we're going to multiply, we need a common denominator, so I'm going to multiply this entire fraction by cosine on the top and bottom, and sine x on the top and bottom. Woo! Man, now I have to write even longer sentence. Okay, so we have, get down here. All right, cosine x, sine x, cosine 2x, plus cosine times cosine is cosine squared x, 2x. Now I'm going to make common denominators, so I'm going to put this minus sign here and a set of parentheses because there's two terms in the second numerator. Sine x, cosine x, cosine 2x. I'm getting really quiet here. I don't want to make a sign mistake in this one. All of that is over cosine x sine x. Okay, now what do we have here? We have cosine sine cosine 2x, cosine sine cosine 2x. This one's positive, and after we distribute the negative sign, that's going to be positive. So cosine x sine x cosine 2x is going to cancel with minus sine x cosine 2x. Woo! That's going to save some writing. And we got cosine squared x sine 2x. So I'm going to have to go up here now. I hate jumping around like this. I hope you can follow it. Cosine squared x sine 2x. Negative times negative is positive. Sine squared x sine 2x all over the denominator of cosine x sine x. Good thing I might still need to erase part of this, so you might want to copy what I'm doing here. Got it? Okay. So probably should just erase the holiday lights for this. Okay, now we got sine 2x and sine 2x. We have that in both terms, so we're going to factor that out. And we're going to pull this out and get sine of 2x times cosine squared x plus sine squared x over cosine x sine x. You're starting to feel it. I'm getting excited. We're almost done. Cosine squared plus sine squared. That's the first Pythagorean identity, and that is equal to 1. So now we have the sine of 2x over cosine x sine x, and that becomes, we've got a double angle and a single angle, so nothing's going to happen until we fix that. So this sine 2x becomes 2 sine x cosine x over cosine x sine x. The cosines cancel out, sines cancel out, and I just did all that work to get an answer of 2. Are you kidding me? Woo! Bam! Mr. True. Go do your homework.